Thank you for stopping by to check out this episode of Vintage Audio Review. In this episode, I'm going to talk about the Soundcraftsmen PCR800 Power Amplifier. Soundcraftsmen began selling these amplifiers in 1984 and the listed price was $449, which translates to almost $1,300 today. It was rated at 205 watts per channel into 8 ohms and 300 watts per channel into 4 ohms at 0.05% THD or less. It also weighs in at about 23 pounds, and one of the selling points of the amplifier was that it used phase control regulation to make it more efficient and weigh less and be able to put out a lot amount of power. Very similar to the Carver M400 cubes that were selling around that same time, although the Carvers are much lighter than these. If you were fortunate enough to have two PCR800s, Soundcraftsmen sold a kit that would allow you to mount them next to each other in a rack mount configuration, and they provided an electronic phase inverter for both channels. They're very hard to find, and so I built my own phase inverter. I will show the schematic for it here, and if you pause it you could copy it, and if you ever wanted to make one. Also, the way that it works is you would take your preamp output, either your left or right channel, and you plug it in here, and then you take the output here, there's a plus and minus, and that would plug into your input on the amplifier here, and then you would take your speakers and run them to the 2 plus speaker terminals on the back of the PCR800. Now what this little device does is it takes the incoming signal and it just inverts it 180 degrees out of phase, so you have the two inputs going to the PCR800 180 degrees out of phase, and the way the amplifier works is that it will just double the level of the signal, and that's how you get twice as much power. I did do some measurements with this running mono, so you have that to look forward to later on. My experience with Soundcraftsmen began in 1981 when I purchased an MA5002 power amplifier, which was rated at 250 watts per channel into 8 ohms when I was in Germany, and I kept it for many years. It's one of those items that I wished I never would have sold. You can find them on eBay. They've gone up quite a bit in price, and I probably will hold off on getting one, but they're a nice amplifier as well. I have another amp that's very similar to the MA5002, another Soundcraftsmen amplifier that at some point I will do a review on. The selling points of the PCR800 was its phase control regulation, which is the PCR, and that was a method that it used to vary the voltage going to the output stage to make it more efficient. I wanted to give a little tour of the front of the unit. There isn't really a lot going on, but I thought what was there I would point out. This front thing, these little lines are just silkscreen patterns on the cover. They're not vents. The venting actually takes place between this plate and the case here. It's maybe out 3/4 of an inch, and so the air comes from the back of the unit through the fan and exits all around here. It never gets really hot, although it can get like a little warm, so you know that it's doing its job. The cooling system is doing its job, but you never had to worry about touching that. You have your power switch is right here. It's a push on off. You have a power LED, tells you power's on. And then you have these two true clip LEDs, one for each channel. The interesting thing about them is after you've powered on the unit, it may take it a minute for those to go off. They glow, and the manual even tells you that's normal. They do work rather well when your waveform begins to get clipped and you start seeing distortion. These do come on. That did happen several times when I tested the unit, and it was beyond what the specifications were, and the waveform was starting to show 0.2, 0.3% THD, and then these things would start coming on. So that is the front of the unit. And this, of course, is the rear of the PCR800, and here are your two RCA inputs, your unbalanced inputs left and right. You have your two speaker outputs, and they are banana jack friendly, and then Here is the cooling fan, sits in behind here, and it draws air forward, and it does have a warning to keep that clear. So here's the PCR800 in all its glory with the cover removed. We'll start with the fan. Here's our cooling fan, which draws air from the rear of the unit, and it blows it across these heat sinks fins it blows it across the heatsink fins for the MOSFET output transistors, which would be all these guys right here. Now these look pretty ugly because this unit came from a marine salvage place in Florida, a marine electronics salvage, not a buried treasure salvage place in Florida. And this could have been on a boat, possibly. It was in an environment that had a salt atmosphere and there was some corrosion on it. There was also a lot of corrosion on the cover of the unit, and I sanded all that and repainted it when I first got it. So coming along, the air would go across the heatsink fins and then it exit out here through the front of the unit. Our two main filter capacitors are this guy, and they are screw terminal lug connected to the circuit board, or the underneath of the circuit board, through these little screws here, or little bolts, I guess. And I did not replace them. I didn't feel they needed to be replaced from the initial data that I saw on them. So all the capacitors on this board were replaced. All the electrolytic capacitors were replaced. We do have some bias adjustment pots here, which were sealed. I did not have a service manual and didn't feel that I wanted to start playing around with them to try to adjust the bias to some level that I did not know what it would be without the service manual. Right here, you can tell there is a burn spot, and that happened due to some grounding issue I was running into when I was hooking up something to the unit. This connects between the ground of the chassis and the circuit ground itself, and I did something and that blew up. Fortunately, there was no other damage. Here is our fuse. There is only one fuse in the unit, and this currently is a 12 amp ceramic fuse, and right here is our on-off switch. Now, I did not replace any of the electrolytics on this board, and there's some over here, mainly because this board looks like a bear to get at, and I didn't want to do it at the time. This is just a more close-up view of what you just saw. You just have a better view of the capacitors down here and the fuse and on-off switch area. It's not really that exciting. So here is a different view of the inside of the PCR800. Here's the power transformer, of course. There is an opening here, a gap. I think there was some material that they used to put around the windings of the transformer that came out over the years. And it doesn't seem to affect the performance of the transformer. I didn't really hear any weird sounds coming out of it that were unusual during the testing that I did. Obviously, here are your speaker terminals over this way. And we do have two more pots here. These actually are the bias pots for the output devices. Pots that I mentioned earlier for the bias setting were for some threshold voltages for the operation of the power supply. And they're all sealed up, and I didn't mess with them. But this just kind of gives you another view of the inside of the PCR800. And here is one last view of the inside of the PCR800, kind of looking down from the top. Here is our little hole in the transformer sealant, or whatever, the seal that they use to put around the windings. And you just have more view of the output devices here. Now what's interesting is it looks like there were 4 more output devices on here at one time. I don't know what's up with that, but they weren't there when I got it, although they look like they may have been there at some point. And also we have our speaker terminals right here. You can kind of see that. And that's about the end of the tour for the inside of the PCR800. Here we have our standard THD SNR plot at 1 kHz with the amplifier running 5 watts into an 8 ohm load, and it's showing about 30 dB of gain. We also have a THD that's less than the spec limit of 0.05% for both channels. The SNR for the right channel is about 10 dB less than the left channel, but the SNRs are still at least in the upper 70s. And here is the THD SNR plot at 1 kilohertz with a 4 ohm load, and you can tell that the performance is not as good. Although the THD is less than 0.05%, the SNRs did get worse, and the right channel is looking about 10 dB worse than the left channel as far as the SNR is concerned. And here we have the frequency response with an 8 ohm load and it putting out 5 watts. And we can see both channels are pretty well balanced within 1/10 of a dB. And at 20 kilohertz, we're only down 1/2 a dB. The spec was plus or minus 0.1 dB. That was nearly 40 years ago. So at 1/2 a dB, I don't think we're doing that bad. And here is the 5 watt frequency response with the amplifier running into a 4 ohm load, and it looks pretty much the same, although the channel separation might be 0.15 dB instead of 0.1 dB, but it's still down 1/2 a dB at 20 kilohertz. Here we have the THD SNR plot at 1 kilohertz with the PCR800 operating at about its limit of 205 watts per channel into 8 ohms. You can tell that it's still meeting the less than 0.05% THD requirement. However, the SNR is at 65 dB, which is 40 dB less than the spec requirement of at least 105 dB. Also, you can start seeing how the harmonics are starting to get some modulation in them at this point. So here I've backed down the power going into the PCR800 so that it's only putting out 180 watts into 8 ohms. When it's running like this, you can tell that the THD and the SNR have both improved greatly from the data on the previous graph where it was showing about 205 watts or so. Also, I did find out that the 105 dB SNR that Soundcraftsmen claimed in their advertisement was based on another factor being measured. And in the August 1984 issue of Audio Magazine, there was a review of the PCR800, and it got quite good marks, but they explained that Soundcraftsmen's way of measuring the signal-to-noise ratio was different than what theirs did by a factor of 23.1 dB. So actually, they were measuring right around 82 dB SNR, so we are better than that. Here we have the THD versus frequency at a couple different output power levels into an 8 ohm load for both channels, and for the most part it is better than 0.08% THD across the band regardless of the power level. So I think it's doing pretty good for a 38-year-old amplifier. So this graph shows the THD versus the output level of the PCR800 at 1 kilohertz into an 8 ohm load, and basically the minus 10 on the x-axis goes up to plus 2. So plus 2 would be 190 watts and the minus 10 is about 12 watts. So you can see for each channel what the change in THD is versus the power level. For the right channel, it doesn't change very much. The THD level stays pretty flat between those two ranges. For the left channel, there is a bit of improvement of the THD at the lower power levels, and then it kind of levels off at the high end. And it's less than 0.01% THD across the band for either channel, which is pretty good. This plot shows the output impedance over frequency for the PCR800, and it's a feature of the QA402 audio analyzer, which I love dearly, that I had not used before. And basically, the lower the impedance of your amplifier, the better. So the worst case I calculate is about, I don't know, 0.17 ohms. And if you take 8 ohms for a load and divide it by 0.17, you get about 47, which would be your damping factor. And typically you want a damping factor greater than 10. That's kind of what this shows. Moving on over to a 4 ohm load, we are getting about 320 watts per channel into the 4 ohm load, and the THD is less than the 0.05%. However, the SNRs are around 60 dB, so that is not stellar, and you can kind of see a little bit of a modulation in the harmonics there. Here we have the THD SNR plot at 1 kilohertz with the power backed down a little bit out of the PCR800. So we're putting about 280 watts into 4 ohms, and the THD improved as did the SNR. Note that the spec was 300 watts into 4 ohms at 0.05% THD or less. This plot shows the THD versus input level at 1 kilohertz for the PCR800 going into a 4 ohm load. At the left end of the scale where it says -9, that is equivalent to about 32 watts. And on the other side, 0 is probably about 190 watts. And you can tell that with the 4 ohm load, like with the 8 ohm load, the right channel is pretty flat as far as the variation in THD versus the input level. The left channel shows a little variation, but either case, they are less than the 0.05% THD spec. So here we have the THD SNR plot at 1 kilohertz for the PCR800 operating in mono into an 8 ohm load, and the THD looks really good. The gain is about 36 dB and the SNR is about 76 dB, so it's not too bad at that low of a power level. And here we have the frequency response for the PCR800 running as a mono block into 8 ohms with a 5 watt output, and it looks pretty much the same as it did when it was running as a standard stereo amplifier, a half a dB down at 20 kilohertz. So here we have the amp running at almost 600 watts into 8 ohms as a mono block at 1 kilohertz, and the spec requirement was that at 600 watts it would be 0.05% THD or less, and we're at 0.07%. That's not too far off. The SNR, however, is 58 dB. That's not great, but if you were playing your music this loud, I am sure you would not hear the distortion caused by that. Anyway, you can see some of the modulation on the harmonics there as it starts approaching the limits of what the amp can do. So here we have the THD SNR plot at 1 kilohertz with the PCR800 running at 457 watts into a 4 ohm load as a mono amp. And you can see that the gain's still around 36. The SNR is a nice 87 dB, and the distortion is less than 0.02%. So I would say that the PCR800 is performing well. So here we have the PCR800 still running as a mono block into 4 ohms with the output power at 699 watts. Now the THD is still, 0.22%? That's not too bad at all. And the SNR has dropped down to 54 dB. That is nothing to write home about. But overall, this is not bad for 700 watts. So here's the THD versus power and frequency for the PCR800 running into an 8 ohm load as a mono amp, and basically it has less than 0.06% THD across the frequency band up to a power level of 325 watts and as low as 200 watts. And this plot shows the THD versus frequency for a couple different output power levels into a 4 ohm load, and this is in stereo. And basically it looks pretty decent from 100 hertz and above, maybe 0.05%, and it goes as high as 0.1% between 20 hertz and 100 hertz. Here we have the PCR800 running as a mono block amp into a 4 ohm load, and this shows the THD versus frequency at a couple different output power levels. They are for 415 watts and 280 watts, and the green line says 415 watts, but it's really 350 watts. I did a typo there. And as you can tell, the THD gets kind of bad at the low end of the band, like around 20 hertz. It's maybe 2.5%, and then it gets a lot better once it hits 200 hertz. It starts getting down to maybe 0.1% or better. And here is the multi-tone data for the PCR800 running as a monoblock amplifier into 8 ohms, and it's showing about 11 bits of distortion-free range. And here is the multi-tone data for the PCR800 running into an 8 ohm load as a monoblock amplifier, and it shows the same 11 bits of distortion-free range. I think the data showed that this PCR800 met quite a few of its nearly 40-year-old specifications. It fell short in a few areas with SNRs, particularly when it was at or above the power level, but overall it did really well, and if you were listening to music that loud, the SNR isn't going to be a big factor. The fan, when it comes on, that is very loud when it does come on, but it doesn't come on when you're listening to real music. When you're testing on a bench and you're driving into loads and you're putting out a lot of power, it's going to come on, but during normal listening tests it never was beyond what the low speed, and you really can't hear that, especially if you have music on. So right now I've got the PCR800 running about 21 watts into 4 ohms, and what I wanted to do was show the effect of what happens when the power gets high enough that the fan kicks on to high speed. So right now I'm going to move the microphone next to the PCR800, just a few inches away from it. And you will hear like a little beeping, chirping sound, and that is the QA402 analyzer's 1 kilohertz pulse going on and off, and the PCR800's response to that with the transformer hum, I guess you would call it. Anyway, I'm going to move the microphone right next to the front of it, a few inches away. And you can hear just a little bit of the fan going. It's not, you wouldn't hear it if you're probably 4 or 5 feet away. And now I'm going to slowly increase the power till the fan comes on, and it's kind of going to vary to how much the unit has been on and how hot it is. But we didn't have this problem when it was running into 8 ohms. It never came on at all. But here we go. I'm going to put the microphone the same distance away as you, and you can hear how loud it gets. Honestly, if you are playing your music at this loud, which is about 50 watts for most speaker systems, it's going to be so loud you're not going to hear the fan. And also, you're probably not going to be playing sine waves to listen to. So that kind of exaggerates the fact, but I just wanted to demonstrate how the high-speed fan sounds when it's turned on. Music on. And I did listen to it hooked up to the Carver C1 preamp and the Klipsch La Scala speakers. I was hitting in the 90 dB SPLs with the amp, and it's hardly even on at that point. But the La Scalas are so efficient, it doesn't take a lot to drive them. Now, I did listen for some hiss with the amplifier hooked up and the volume at mid-range on the preamp and no signal going in, and yeah, you hear some hiss. If you back away about 3 feet, you don't really hear it, and you're not going to hear it once the music's on. And that seems to be normal with the couple of amplifiers that I've hooked up to the La Scalas, or probably you would have the same effect with any horn speaker. As far as the quality of the sound, when I was just listening to it, it sounded fine, just like most power amps, and it had plenty of oomph to get 90 plus dB SPLs. I would recommend this amp. I'm not sure how much I would want to use it in a 4 ohm system. If you're really going to be, if you had a 4 ohm speaker that's going to take a lot of current, this seems to be more sensitive to the 4 ohm loads. It would come on, the fan would go to high speed quicker than with 8 ohm loads. When I was doing a lot of the 8 ohm testing, the fan never switched to high, but during the 4 ohm testing it would at a sooner level. But it did have good numbers at 4 ohms, and like I said, I doubt the fan is ever going to switch to high during most of your listening. My theory is that you can never have enough hard drives or power amps, so this is one that I use for other tests. One thing I forgot to point out earlier is that the data sheet that came in the owner's manual, of which you're going to see in just a moment, it actually tested the ability of the Soundcraftsmen to drive a short. They shorted out each channel. It looks like 10 times in this particular data sheet, and they made sure that the amplifier survived shorting out. So maybe you could weld something very lightly with this, but they really cared about how well their product would survive, and they did do that kind of test. I'm not sure very many manufacturers did a test where they shorted the outputs. If you know of any, let me know in the comments. Once again, I do thank you for watching, particularly if you watched all the data, and I would ask if you haven't subscribed to please do so. The main reason for that is if I'm talking to a friend or a relative, they go, oh, how many subscribers do you have? I can say I have X number, and it's more than just friends and family. So I do appreciate when you do subscribe, and I've had some interesting conversations with you in the comment section, so I look forward to those so far. Once again, I thank you for watching, and have a great day or night.